Hello, sound check. Okay, hello, good afternoon. It's my first time here in Ukraine, and so far I'm feeling it's awesome. Awesome audience, awesome people, awesome venue, awesome conference, but I'm feeling a bit cold because I'm Brazilian. Okay, it's a bit cold for me, but it's a great pleasure to be here at the JavaDay conference. And I'm going to talk today about how to break your monolithic database. I've been talking about microservices for a while, and the number one question that I always received in my sessions was, but I have a relational database, I have a monolithic application, how do I break my database into separate microservices database? So I'll try to answer some of these questions in this session. I'm a director of developer experience at Red Hat, and my Twitter handle is @Yanaga. I'm pretty sure, I don't know how many of you were here at the Burr session, but we're giving away some swag, some stickers, some t-shirts, nice t-shirts. So if just tweet a picture of us and mention us at Yanaga or at Burr Sutter and the hashtag JavaDay 2016, we have some swag for you. I'm also a Java champion and a Microsoft MVP, which might sound like interesting because having these two titles at the same time would be an impossible thing some years ago. But that's one of the interesting things of this new world because everything is changing. And if you think about it, in the end, open source has won this battle. So nobody's talking about if open source or closed source. At least in Red Hat, we believe that open source is the best way to develop software. So that's how we keep pushing it forward. And I always like to start my sessions with this sentence, not from me, but for Forbes. Now, every company is a software company. I like to say that you don't work for a bank, you work for a software company. You don't work for an industry, you work for a software company. And some of the degrees in this new digital economy, where everything is software-based, some great examples that we have today is that the largest car transportation company in the world owns no cars, which is Uber. The largest lodging company in the world owns no real estate, which is Airbnb. The largest online retailer in the world owns no stock, which is Alibaba. And the largest content network in the world produces no content, which is Facebook. All of these companies have something in common, is that they are all enabled and they are all possible because of software. So software is changing the world, and I always like to introduce myself as a software craftsman because the best definition that I have about a software craftsman is someone that cares about their job. So I believe that software can change the world, and we can change the world for the better. We can change the people's lives for the better with the software that we do every day. We can also make them miserable. Some years ago, I made a choice. I decided that knowing how to feel miserable, because we know how miserable we feel when we use crappy software, or software that is not made up to our expectations. So I decided I wanted to change people's lives for the better, and I know that I can do this with software, because software is going to change everything that we have in our lives in the next 1,000 years. So if you think better about the subject, I can say that we developers, we are the most important people in the world in the next 100 or 1,000 years, so we have a great responsibility in that. And talking about delivering software, better software, faster and safely. Everybody these days is talking about DevOps and microservices, so we can deliver this software more reliably into production. And if I got to say one of the most important aspects of software development, any kind of evolution or revolution that we had in the past 20 years in the software development process, they always try to improve what we say, or what we call the feedback loop. And the feedback loop is very important for our humans because that's the way we improve with the things that we're doing. That's the way how we learned to talk when we were kids. We did the feedback loop to say, oh, I'm saying some sounds. I need to know if they're forming words. We need the audio feedback. We need our parents and grandparents' feedback to say if we were speaking the things correctly. And in the software world, we need the feedback loop to check. I type something, then I compile. I need to know if my code is going to work. Then I write some tests. I run these tests. I need to know if I'm not breaking something else. And the best thing to check if something's working or not, if we think the software development process as a scientific thing, Usually you have a problem, then you formulate some hypotheses. How can I solve this problem? Quickly you just eliminate some hypotheses, and then you try to validate the hypothesis that you think are going to run with code. So when you code and you run it and you deploy that into production, you check if your hypothesis is correct. So the faster that you can check if I'm going to solve this problem with this code, let me check if it runs into production, the faster the feedback loop is, the better the quality of your software. And not only, I'm not only talking about code quality, but also value quality. Because imagine the business people, sometimes they have something in mind. I think that if I change or if I add this functionality, if I change the color of this button, I'm going to sell more. It's going to be better for my user. But sometimes we take like 6 months or 2 months to deliver the functionality. And when that happens, many things that the business people were thinking about when they asked you to implement that are no longer valid, or they even forgot why they asked you that feature. So the shorter the feedback loop, the better software you deliver, not only in terms of code quality, but also in terms of business quality. So we always need to improve this feedback loop. And we were talking about DevOps and microservices. Everything that we do in DevOps and microservices is to improve the feedback loop that we have every day. So imagine you have a lot of different things that are going on when you deploy your software. You usually create a lot of code in 1 week or 2 months that you're working on that. So you just create a huge software code base, and then you try to deploy that into production, and of course something fails. And when that something fails, you have a very hard time trying to figure out what is the specific thing that I changed in the last version that is breaking my code base into production. And I always like to say that I used to be a software consultant, and in the many companies that I visit, the #1 reason for not deploying software faster, for not reducing the feedback loop, is that we have too many bugs into production, so we can't deploy faster, so we need more time to test. But then when you need more time to test, you also have more time to code. So testing time is never enough, because you just produce more code and you need more time to test, and you have more bugs into production. So I always like to do this very simple, simplistic correlation, that what causes bugs into production? Okay, I like to say that it's code. Code that does not exist, does not produce bugs. So the more code that you write, the more bugs that you have into production. So the anti-natural way of solving that, or the natural way, depending on the point of view, is to test more, have more time to test. But in DevOps and microservices, we're trying to reduce the things that we deploy into production, so that we can eliminate a lot of different aspects of packing a lot of things together that leads to bugs in production. So in an ideal world, if we were able to reduce the things that we do in each one of the releases, if you just deploying one single commit into production every time, if anything goes wrong, you can guess what are the lines of code that are producing that bug. So I changed these 5 lines of code, I deployed, and I have a bug into production. Where is my problem? The problem lies on that five lines of code that I just coded and deployed into production. So it's much easier for me to spot the problems when I deliver bugs. So it's much easier for me also, instead of rolling back in a version, it's much easier for me to just fix it and deploy into production. So my feedback loop is much better. So when we're talking about delivering software into production, the most important thing about DevOps and microservices is try to reduce what we call the batch size. So batch size is a technical term that we use in the DevOps and microservices world. We try to reduce the amount of things that we release into production in each one of these releases. So batch size is very important. We need to reduce that to a minimum. But if you really put some time and put some work on reducing your batch size, you will still have a problem, because we have something called maintenance window. because we can't deploy multiple times per day if we're going to disrupt our users. We can't just, oh, the users are working on that. I'm just going to stop the server and deploy a new version. Then I have 5 minutes downtime. Everybody will be very happy for me to stop the server in the middle of the day, and everybody are going to lose what are they doing. So I just can't start deploying multiple times per day if I have a strict maintenance window, because I can't disrupt users. So your maintenance window, sometimes it's once a week, sometimes it's once a day, sometimes people stop to have lunch, it can be twice a day. But you see, you're never going to be able to do more if you have a maintenance window. You're never going to be able to deploy faster than your maintenance window, which is usually regulated by your ops team instead of your developer team. So to be able to reduce our batch size even further, we need to allow zero downtime. And for us to be able to do zero downtime deployments into production, we need some requirements. One of them is to have a blue-green deployments, which is a very common deployment scenario these days. And we're talking about what is a blue-green deployment. Blue-green deployment is basically you have multiple clients issuing requests to your server, to your deployments. We call that blue. Then changing in the software architecture of my deployment, I need to add another entity called usually a proxy. Can be many different implementations, can be a load balancer too, but for now it's just a proxy. And we add another deployment to our architecture. So now we have two separate servers servicing requests at the same time. So we need some way of externalizing our state. And we usually use Memcache or Redis or other kind of in-memory cluster to store sessions, for example. Or we have a cluster for that, too. So we have two different deployments. And when we want to update our release, we just phase out the green deployment for that. We update that deployment. We wait for that to warm up. When it warms up, we just put it back on the cluster. We disable the blue one. We update the blue one. We wait for that to warm up. And when it's ready to serve requests, we put them back in the cluster. So blue-green deployments basically means that you always have two different servers or two different deployment servers for you to be able to update one, while the other one is servicing the request. Then you switch that, and when both are working correctly, you can let both serve the requests. So you need to double the capacity of your infrastructure to be able to handle blue-green deployments. So, but blue-green deployments are relatively easy to implement in your server infrastructure. And I always like to say that codes is very easy. Because you code, you just undeploy your artifact and deploy the new version. It's already running. You don't have to worry about other things. But state is always hard. How do I handle the state that is in the session of my users? Sometimes it's going to break. Sometimes it's going to not break. But since session state is usually ephemeral, I'm just comfortable saying, oh, the user must just restart the workflow that he was doing. So if he's going to lose something, he's going to lose like 5 minutes of his work. Maybe it's not a big issue, but ideally, I would not discard the session state. But when it relates to the database, it's much harder to do that. So I have a relational database, and a relational database is just a permanent storage of data. And when I'm issuing some blue-green deployments, now I have a bigger problem to deal. It's not just zero downtime, but now since I have a blue-green deployment, I have to be able to have two different servers working with separate versions, working at the same time. So it's not that easy to work with relational database when we're doing blue-green deployments in zero downtime. So we need some techniques to achieve that too with relational databases. And the first option, of course, it's we need zero downtime migrations. We don't have the option of, oh, okay, I'll update my server, but migrations, I don't know how many of you are familiar with this term. Migrations is the set of alter table statements or updates that you do between one version and the other one to update your database schema to the new version. So we need some kind of zero downtime migrations too to be able to release our software without downtime. And when it relates to zero downtime migrations, it also means that with blue-green deployments, we need our migrations to be back and forward compatible. But how can we do that? One of the first requirements is that our migrations, now we can't just do a bulky update of tables and up in rows and everything else. We need to do baby steps, just like refactoring. We need to do baby steps to the smallest possible batch size. And when we're talking about batch size, usually it's just one command per migration. And we have another problem when we create an alter table statement, or when we create an update table, update column, update rows statements. It's gonna take a long time depending on the size of your table. So we can't afford to be locking the table for 5 minutes, because that means downtime too. So we must, if we have too many rows in our table and we issue some alter table or update statements, we need to prevent these long locks. So we also need to shard our updates. What does shard mean? Shard means we need to split our data set into smaller data sets so that we can upgrade that small data set without downtime. And what does it mean in terms of SQL code? In terms of code, I used to do an alter table, customers, rename column wrong to correct. That's the usual way of delivering updates to production. Now when we're talking about zero downtime migrations, I need to do more than that. Instead of just issuing one SQL statement, I'm going to have to create a lot of them just to allow zero downtime. So that's one clear example. Instead of just renaming a column, I have to first add a column, update my data set without locking. I suppose it takes a long time to update the records. To copy the one from the other, I have to update customers, set correct equals wrong, where ID lesser than 100 and lesser than 200 and bigger than 100. So then I need a series of code updates. Then later I can delete the column. Okay, so the basic idea here is that I'm not gonna execute destructive statements in my DDL. And I'm gonna need a lot of baby steps, SQL updates to my code base to allow for zero downtime migrations. So some of the common scenarios that I've collected in the past months for zero downtime migrations usually are add a column, rename a column, change the type or format of a column, and then delete the column. And if you think about tables as just a set of multiple columns, you can apply the same refactorings that I'm going to show you after into a set of columns in a table too. So first scenario, I want to apply zero downtime migration to add a column. Add a column is the simplest one. First, you create a release, add in a column. Then you create another release using a null or default or computed value. If you create a computed value, you need to shard your update statements too to prevent locking. And then you start using the column in your code. So to allow zero downtime migrations with blue-green deployments in production, you need to separate your deployments in at least 3 steps. So instead of doing just one release, you're going to create 3 small releases of your codes with 3 separate migrations or code changes in each one of these releases. And each one of these releases is back and forward compatible with the previous and the next one. Okay. Another very common scenario, rename a column. Then you're going to, first step, add a column in your database. Next release, you're going to copy the data using small shards. For each one of the shards, you're going to create a separate release to prevent long locks. And third release, your new code base is going to read from the old column and write to both columns, old and new. Your fourth release is going to read from the new column and it's going to write to both. And in between step 3 and 4, you can manually check if I'm writing the right data into the new column. After 4, also I can automate that, or I can manually check, is my code writing the right values in the new column? I can compare the columns to check, does the value between the old column and the new column are correct or are the same? So I can do a manual automated checks on that too. And in deployment 5, my code will be reading and writing from the new column, but the old column is still there because I can't do destructive statements in my database. And later, maybe a month later or a week later, it depends on on the schedule of your cleanup of the database, I'm going to delete that old column, or I can leave the column forever until I think it's no longer necessary. So these are the 6 steps, at least 6 steps that you need to allow your code to be deployed with migrations into production with zero downtime. And another common scenario is to change the type or format of a column. And if you, I'm going to show you this, change type and rename a column, you see that's exactly the same set of refactorings that you never modify an existing column. You just create a new one, you migrate the data, your code reads from the old one and writes to both, your code reads from the new one and writes to both, then you just start using the new column, because you can add multiple intermediate steps to check if your code is running or writing the right values. So this way, you can easily roll back your version, and your data is still there, your code is still compatible with the previous in the next version. Okay. So rename, change type, and the last one, delete a column. First rule, don't delete columns, because delete is a destructive statement. You can't do that. You just stop using and reading the value from the database in your code. Then you just leave the column. If that column is like a non-new value, you can alter the constraints to allow a new value, for example. Or better than that, you just keep your code right into the column until you believe it's no longer necessary. So that's my recommended approach too. And then a week later, or a month later, or 2 months later, when you decide to do a cleanup in the database, and that column is not used anymore, like for 40 releases, then you can just delete the column, because nobody else is using that column anymore. So that's the small refactors that you can use to do zero downtime migrations. And next question is, okay, columns are easy, but what about my referential integrity constraints? And if you think about referential integrity constraints, it's just like one of these columns must reference the data from the other column. But thinking about your domain model, referential integrity constraints are not necessary. It's just are not needed. It's just a safety net that you use. But you're thinking about zero downtime deployments. The answer is very easy. You just need to drop the constraints, modify the columns, and later, when everything is okay, you just recreate them when all of the migrations are done. So it's not a problem to have referential integrity constraints in your code base and applying zero downtime migrations. In fact, it might seem a lot of work doing all of these 6 steps for just a simple rename column or change the type of column. And I agree, it's a lot of steps. But all of the companies that I've visited that implemented successfully zero downtime migrations, they can't simply look back and see, oh, we used to do the database migrations the hard way, because sometimes you just do a SQL statement, you just get it wrong, then you just have to recover the backup, and it takes a long time. So it's something that they don't have to worry anymore, because now they never do the destructive statements, and they always have multiple compatible versions in production. So it's much easier for them and much safer for them to be deploying software into production now with these migrations. So I recommend all of you to be doing so. But that only covers the zero downtime migration of the microservices or traditional monolithic databases. Now, the next question that I need to answer is, I have a monolithic database, and one of the best practices about microservices is that each one of the microservices must own its own state, and it means it must own its own relational database, or later you can change your relational database to another kind of data store. But we'll start just with relational database. And to tell you how to do that, first I need to talk about just a bit about architecture, because everybody's talking about microservices, and of course the discussion arises to the point of CRUD applications and secure RS applications. So I'll try to explain very simply to you what is CRUD and what is secure RS from a relational database point of view. So traditionally, applications using CRUD is the create, retrieve, update, delete architecture. You use the exactly same model to do all of these 4 operations. So if you have a customer, you read, you create, you update, and you delete the same entity, which is a customer, and you're writing and reading all of this data from the same database. So write operations and read operations are all issued to the same database, to the same tables, in the same data store, in the same schema of your database. When we're using CQRS, and it's very hard to find a simple explanation for CQRS in the internet. Of course, it has much more than that. But if you're just talking about relational databases, CQRS basically means that we're going to use separate data stores, separate tables, possible separate schemas, or even separate database instances for that. We're going to use separate data stores for write operations and for read operations. It means that you're reading your data from a table and that you're writing your data into another table. Okay? It might seem confusing, okay, but it works in practice. I'm going to show you later. I have a very cool demo using Debezium for that. But CQRS usually means also if you're writing and reading from different database, it also means that you're going to use event sourcing at some moment. So, but ideally, when we're talking about microservice, at any time point of the moment, we're going to reach a CQRS architecture. So I'm going to teach you some of the steps that you can use to achieve this kind of infrastructure, dealing first with a CRUD database, which is a monolithic database. Then we're going to apply some steps to reach, in the end, maybe a CQRS infrastructure. So some common scenarios for achieving this migration from monolithic to multiple microservice database. I need to first create another database that I'm going to use in my separate microservice. And my microservice can be a read-only microservice or can be a read-write microservice, depending on my architecture, depending on my requirements, and depending on the technique that I use to create the separate database. Some common scenarios that we can use to create this separate database. Usually copying the data from one place to the other means I can use a view, I can use a materialized view, I can use a mirror table using trigger, a mirror table using transactional code, a mirror table using ETL tools, and I also can use event sourcing. Each one of these has these trade-offs because it's all architecture. Architecture is all about trade-offs. I'm going to issue some trade-offs between all of them. First scenario is a view. View usually is the easiest one to create a separate database or a separate schema for your data. It has the largest support in all relational database available. It has some possible performance issues. Depending on the way that you create your view, you can have some performance issues. It has a strong consistency. I'm going to create a parallel here. What is a strong consistency and what is eventual consistency in distributed systems? A strong consistency means that in any instance of time t, any client issuing a read statement in your system is going to get the same value. Okay? Doesn't matter the client. Everybody issuing the same select statement is going to read the same value. That's a strong consistency. Eventual consistency means that at any instant t of time, I may have multiple clients issuing the queries for select statements, and they might read different values, but eventually, all of them will read the same value. You mean that all of the values are correct, but not all of them are updated yet. So eventual consistency means eventually all of them will converge to the same value, but you might have stale reads, meaning that some customers or some clients might have old values while they're reading the values in a distributed system. So one of the advantages of using a view means that you can use a strong consistency because you're just dealing with a view of your database. One database must be reachable by the other, which means if you're using Oracle, you need to use a DB link. And depending on your database, your view can also be updatable. Some databases have updatable views support, so it depends on the technology that you're using. Next scenario is materialized views. Materialized views have better performance than views because the implementation of the relational database that we have today just use tables underneath to use materialized views. It can have stronger eventual consistency, depends on how you create your materialized view. If you create a refresh immediate database on materialized view on Oracle, and every transaction that writes to your original table, it's gonna on the same transaction is gonna update your materialized view too. So it has a strong consistency. But one database must be reachable by the other two. You can use a DB link for that. And depending on your database too, it can be updated or not. Depends on the implementation that you choose. Next scenario is mirror table user trigger. You can create a trigger on your original database. It depends on database support. Not all databases these days support triggers, but many of them support triggers these days. Triggers always execute on the same transaction, so it has a strong consistency too. One database must be reachable by the other, and you can use DB links depending on the database implementation too. Other scenario is mirror table using transactional code. And when I say transactional code, it can be any code. You could be using the store procedures. You can be using distributed transactions using JTA. It depends on your support. You can be an external source. If you have any kind of distributed transaction protocol, XA and two-phase commit, you can use this kind of code. It varies very much. So store procedure or distributed transactions, you might have some cohesion and coupling issues depending on how you code your solution. So it varies very much too. And this approach might be updatable or not depending on how you implement it. So it's a question mark because it really depends on the technology that you choose, but it is a possibility too. Another scenario is mirror table using ETL. ETL, extract, transform, and load. Usually it's a beautiful name for BI tools. People use that to extract information from multiple data sources. Of course, you can use that for a single data source using ETL tools. You have a lot of available tools in the markets to use to create ETLs. And people usually use ETL tools to create beautiful dashboards, but you can use to create your microservices too. Requires an external trigger. Usually it's time-based. You configure in your ETL tools. I want to update my data source every 30 minutes or every 5 minutes or every day. Depends on how much your query takes to execute and update the values. You can aggregate from multiple data sources. That's one of the options too. And usually, if not all the times, when using ETL tools, you just create multiple selected statements in multiple different data sources. It means that the database that you're creating for your new microservice is read-only database. So you have this restriction. And the final, and maybe the best one, for your final architecture for creating your microservices, you can use event sourcing too. When you're using event sourcing, means that the state of the data that you have in your application is not represented by a single column or a single row in your database. It's represented by a stream of multiple events. When you create a stream of multiple events on your database or in your system, usually it eases auditing for your records. Usually it also means if you have event sourcing, usually it means that you have event consistencies too. And if you have event sourcing architecture, one of the requirements is that you're going to need a distributed stream through a message bus. What do I mean with event sourcing? I'll give you a very simple example. Usually when I'm updating a customer, I use a CRUD architecture because I create, retrieve, and update and delete a customer using the same customer. But when I have an account, when I store money, usually I don't have to store the amount that I have in the account table in my database. How can I do that? Instead of just storing the current amount of money in my account, I can store that information as a series of events called transactions. So each one of the transactions, I have an initial state which is $0 or zero something, which is the current currency in Ukraine. I tried to, but I don't remember how to pronounce that, but I know it's hard. Okay. Huh? Grivna. Yes. Okay. I hope it sounds almost correct. So you can have 0 grivnas, and you have transactions to add and to remove money from your account. And you see, if your system is deterministic, if you apply the same initial state and the same sequence of events, you always get the same result. So instead of just storing the current amount, you just store the state of your system as a series of events. And you know, many different microservices in your application can store the current amount of your account as a cache just for performance reasons, but the real state of your account in your system is represented by a series of transactions stored in some database somewhere in some microservice. So event sourcing means that your state is represented not by a single column in a single row, but instead as a series of streams stored somewhere. And you can guess that if you have a series of streams, and if you can reproduce the result every time that you apply the same transactions, then you have an auditable system. That's why usually when we're talking about money, we use event sourcing. And we didn't know that it had this name some years ago, but now you have a fancy name for using this kind of architecture. It's called event sourcing. But event sourcing requires that you plan your architecture for doing that. I needed to plan my account system to have multiple transactions to update the state of my data in my database and in my application. But what if I have a legacy application? What if I have a legacy relational database and I want to apply event sourcing to solve this problem? So we created a very cool open source project called Debezium. You can check this project, debezium.io. Debezium, it's called Debezium because it's DB, and the Zion is because they wanted it to sound like something from the periodic table. So it sounds like a chemical element. So it's Debezium. But Debezium basically is a very cool project built on top of Zookeeper and Apache Kafka. I'm not going to explain the whole architecture of Debezium, but in very simple terms, Debezium is a software that plugs into your current relational database and starts reading in your database log for changes in your database. So any insert, update, delete, alter table, create table that you do in your current database, it is streamed through Debezium. Debezium captures this information and distributes this into a Kafka stream. Kafka is a very reliable and fast and persistent message bus, which means it never loses a message, and is also it's deterministic, which means that each one of the Kafka customers or clients, they always receive the same messages in the exactly same order. It's important because if you're applying transactions, the order is important. Okay, so Kafka is sequential, is ordered, is reliable, and is persistent. So Debezium basically reads the changes in your database and distributes that in Kafka. So the reliable and the distributed part of Debezium is done by Kafka. And then when you receive the events from Debezium, you can do whatever you want with that information. You can create a replica. Just that is, I have a database, I'm going to create a replica in another microservice, or maybe I have the full customer information. I don't need all of the customer fields. I just need the fields from the customer table that are required for me to generate a report. Or maybe I have here a transaction table with multiple requests, add value, remove value, subtract value, and everything else. I don't need all of the log of transactions. I just need to have a cache of how much each one of these customers have in their current account. So I can do whatever I want with these events. And I'm going to show you how these events works, and so the multiple possibilities that you can achieve using Debezium. So I'm going to create I have some cool demo here. And I just left it running because it takes some time for it to work. So I have here, I have a Zookeeper, I have a Kafka, I have a MySQL database running, and I also have the Debezium connector running plugged into the Apache Kafka. So I have my cluster set up. And I have 4 different daemons running, but they're all very lightweight. So it runs on my notebook. And I have Debezium plugged into my MySQL database. So I'm going to try to show you here what happens. I have a MySQL database. I'm going to show tables. Use inventory. Show tables. It's small. So I have a table customers, order, products, and products on hand. I configured Debezium to just listen to the customer updates. So if anything changes in orders, products, or products on hand, it won't be broadcasted through Debezium. So you can select which tables you want to listen for events. So each one of the update things that I do, or order table things that I do in the customers table are broadcasted through Debezium. Some get here. Okay. So I'm gonna copy here. I can what? I can update a customer. So just let's first select everything from customers. Then I have these fields. You can check Ann Kretschmer, ID 1004. If I issue an update statement, now it's Anne Marie, the ID 1004. So you can see this update was captured and broadcasted through Debezium. I'm just going to format this information for you to see it more clearly. So if you check the JSON that Debezium generated, it has everything. Debezium, it broadcasts the whole schema of the table in each one of the messages. But the most important part for us is that you have a payload field, and below it broadcasts you the before, how was the row before, and what is the row after the updates. So you can see it was Anne, and now it's Anne-Marie, and nothing else changed. And you also have the operation. The operation is an update statement, so you know what to do with this information. When you receive these events, you can implement your own logic. Oh, maybe I'm going to replicate this information in my new Microservice database. So you can use this to update your own table in your new microservice. And you need to save all of the fields. You can save just all of the fields that you want, which are significant for your current microservice. So I can also do some delete. If I come here and delete the customers, I can see Debezium generated two additional events. So I can just do that. Oh, type it wrong. Pipe. So I have two different events for a delete. A delete means it was before payloads. Okay, before I had this data, and after that I have null, which means I have nothing. So I delete it. So I have the operation delete. And then Debezium generated another event called with schema null, payload null, and the payload is just the ID of the application. Why is he doing that? Because maybe when you're consuming your messages, if you know, maybe you get the whole message, you receive the insert, update, and then delete. If you just read in the final state, why are you going to insert, update, and delete if the final event is a delete? So he's just compacting the stream of events. So if you read in the final event and you have this information in memory, you can just skip all of the previous statements of the same ID because it's not going to matter for the final state of your application. So it's just an optimization that Debezium is doing in the events. Okay. So Debezium also is reliable. I'm not going to show that right now, but if you just stop the Debezium from running, if I just prevent it, if I just stop the connector from running, here, I stop it, I can issue multiple inserts in my database. If I run it here, I changed my database. But if I do multiple inserts, then it's not going to generate the events because Debezium is stopped. When I get here Debezium and turn it on back again, run the Debezium again, it's going to capture the log in the exactly same point that is stopped. It's going to broadcast the events that happens between the stop and the start again. Okay, that's one of the cool Debezium features. Right now, Debezium supports MySQL, MongoDB, PostgreDB, and Oracle. And PostgreDB and Oracle, it's a work in progress. So we're improving the things that we're doing with these two different connectors on Debezium. So expect much more things to come. I'm pretty sure that many of you use an Oracle database for running your monolithic applications. So when it runs when Debezium reaches final, Its final version is going to be a very kick-ass application for you to start your event sourcing. And that's some of the things that I would like to tell you about how you can migrate your monolithic database to your microservice database. All of this information will be published on developers.redhat.com. I'm also writing a book about the subject, so expect it to be published on the beginning of the next year. It will also be available for you to download on developers.redhat.com. And I've been collecting many of these information in the past months from many different people all around the world. If you have any different scenario or if any different optimization or technique that you can apply into microservices, I would love to hear your feedback. And if you want to ask me any questions, my Twitter handle is also @Yanaga. My email is yanaga@redhat.com. And that's what I wanted to tell you for now. Thank you very much. We might have some time for questions. So if anybody has any question.
Just maybe a stupid question. What about atomic operations? Let's say you turn off foreign key constraint, then made migration, and trying to turn it on, but something goes wrong, and this constraint doesn't allow you to
recover.
Doesn't work.
Okay, so you're saying that you're trying to apply a migration, a zero downtime migration. Something goes wrong, but then you can roll back or everything else. Okay, so that's one of the important things. First, to be thinking about microservices, you need a very established deployment pipeline. And when you have a deployment pipeline, it also implies that you're not going to rehearse your migration into production. You're going to have rehearsed your migration multiple times in your development machine, in your test machine, your QA machine, so you know that at least your script is right. So, but even if it goes wrong into production, all of the techniques that I passed, that I show here, means that we're never applying destructive migration into production. So even if you're doing the wrong update, or if you're doing the wrong alter something, you're just adding information. You're not modifying an existing information. So if anything goes wrong, you can just roll back your current deployment, get it to, you usually do this. You do the blue, you do the green, and you check if everything, you do the blue, then you check if everything was working. Oh, I screwed up. Oh, no matter. Stop the deployments, just let the green working, then you roll back the version of your previous one, and everything will be okay because we're never issuing destructive statements on our database. So I think it's one of the best benefits of using zero downtime migrations is because you're always able to recover things into production. I don't know how many of you did that, but sometimes you want to update or delete a column and you just forget the where clause, and it just sucks. You know, you have to just restore your backup, and in one case I did it once, it took but the production backup took 8 hours to restore. So it was a full downtime day. Yeah, some people were very upset about that. Yeah.
Thanks for your talk. So, excuse me.
Oh, here.
Thanks for your talk.
Oh,
it was really practical. So, a quick question. I think the answer is no, but still, so those approaches to zero downtime migrations and in general those principles that you outlined, are there any tools that could, automate partially what you've been talking about?
Well, not the steps particularly, but if you want to apply these tools, in fact, I saw in the schedule, there is a session, I believe, tomorrow. They will be presenting FlyawayDB and Liquibase, which are two migration tools. My favorite one is Flyway, but they both do the same. And one of the important things, when you need to automate because you're not going to do 6 separate steps, each one of these manually. It's impracticable, so you need to automate that. And one of the best practices that I can tell you, because sometimes people use Flyway and Liquibase, attach it to the deployment, attach it to the application. So when the application starts up, you run your migrations. is a bad idea when you're talking about cloud and containers, etc., because it presumes that you only have one instance of your server running at the same time. But when you're spinning like in a container cluster, you have multiple instances being started up at the same moment. So each one of them thinks, oh, the database has an old state, I'm going to run the migration. So everybody will be running the migration at the same time. Some of them will fail, so the application will not start up. So when you automate your migrations using a tool like Flyway or Liquibase, you have to attach the migration process not into the application, but it has to be a step on the deployment phase. So I'm going to deploy the software. I have to apply the migrations, then I have to start up my server or my application. So that's one important consideration. But it didn't talk about Flyway and Liquibase on purpose, because you're going to have a session tomorrow. I don't know who, but it's going to talk about that.
And another question. So how do you approach verifying that migrations are correct ones before applying them on production? Because I know there is a way, like a golden copy database or something, because sometimes you may have a database somewhere in staging that has issues, and then you apply migrations, they work, but then on production, when the real user data sits, you may end up with some migrations being just, with errors, for example.
It's very important that the staging database is exactly the same as the production one when you want to apply the migration. One of the things that prevent people from doing that is that restoring the backup of the production database into staging takes like 24 hours, depending on the scenario. That's why people don't do that often. But usually in the DevOps practice, what fails, you have to do more and not less, or else you have to rehearse. I always like to say that for your development machine, you're not going to copy the production database, but you need a small data set that is practical for you, but can represent, it's an abstraction. You need a small data set that can represent the data that you have in production, so you can rehearse that. So at least on the test data set, you're going to practice that. On the test database, can be a bigger one. And if you're using Vagrant and Flyway and other tools that you can use to populate your test database, one of the things that you can do, you can also snapshot your database from staging and just recover your snapshots instead of trying to restore the backup. You can have multiple snapshots and just recover. Oh, I'm gonna restore the snapshot of the database from the physical point of view, okay, and just run the test and then deploy that in production. I did it once, even using an Oracle database. I spin up a container. I just created a dump file, not that big one, but I created a dump file, then restored everything to the database. Used to take a long time, but since I have an initial state and I'm just applying what changed from one version to the other, it was pretty fast. It ran took like 5 minutes to restore to my staging database to something like my production database. And in this particular case, I was confident enough that the database was real to rehearse my deployment migrations. Okay? And I think we ran out of time. If you have any questions, I will be available at the conference. And don't remember about the tweaks and pictures. Me and Burr, we have a lot of t-shirts and swag to give away. Thank you very much again.